Hey, hello. I am going to tell you why the Monarch 10EE is the best toolmaker's lathe of its size and type ever made. And let's get into it. Being here in this part of the country with all the government entities, such as the Hanford Nuclear Reservation, where a lot of this World War II era equipment came from, the part of the Manhattan Project, about 50 miles away from here. And so a lot of these machines are used in the development of nuclear energy and nuclear other things. And they machine all kinds of difficult materials. And some of the materials are kind of odd. And one that comes to mind, I was talking to a fellow the other day, and it kind of a basic one you may have run into is like cast alloy, which is I'm trying to remember what they call that, a refractory metal cast alloy. And it is just really tough, and it can be extra tough and terrible tough. I saw an ad on YouTube where some companies offering solutions to dealing with cast alloy. Well, this machine here can deal with that kind of material. And one of the reasons, and harder and worse material, but the metal removal rate is not great, but the accuracy is fantastic. And it's almost like the harder material is, the better this thing works, with exotic tools and exotic carbide like Micro 100 that some people know about, but not everybody knows about. It's, I think that Micro 100, I use it on Monarch 10EE for finishing pre-hard steels and just general purpose. It's because the edge resists chipping. That's real important, because if you're on the finish cut and the edge chips, you just ruined your part. It's just terrible. I got a little note here because I can't remember all of the machines that have been around here. And okay, the Hindi toolmaker's lathe, I believe they called it a gauge and toolmaker's lathe. Now, that machine's been around, and I can tell you, it's just a fantastic machine, but it had drive problems. And it's a machine that used a motor generator at a time. It also used vacuum tubes. And then it also used semi-solid state, and this is all direct current drive for variable speed, selenium rectifiers. They smell real bad when they burn up. I've run into it. But those used to be around here, but they just didn't make very many of them. And they needed to be repowered. So when they were sold here, they went somewhere else. I don't know anybody that has one, but I know some viewers have them. Okay, now that one kind of went by the wayside. Hindi. I'm trying to think what happened there. It seems like somebody came along after Hindi went under. I think Barbara Coleman or some company continued the Hindi for a while, but I could have that mixed up with another one. And the next one here is Lehman. Now, that's an odd machine, and they tried to get into the government game in the 1970s by coming up with a tool room lathe. Had a ball bearing spindle. I can't remember what the drive was. I never operated one, and I don't know anyone that has, but I remember seeing them at the auctions. So I don't know what the drive system is, but it would be a variable speed. Now, here's an interesting one. Here is Sydney. Now, Sydney made a machine that had like a George Jetson. It was really kind of rounded square, but on the very top it had a little George Jetson, like, I don't know, little screen thing that showed the RPM. And those were also branded by Southbit, a 14-inch, but pretty short centers. And I have no idea what the drive in those are. And again, those are extremely rare, but I've seen them. I've seen them sell, but I don't know. And now here's one that people like an awful lot, and that's Wheeler. And some of those are still around here. Wheeler's really a pretty interesting machine, kind of under the radar. And the other one, it's Shoblin. Now, the best Shoblins that were around here were the early ones, the 102 VM. And I did have an occasion to run one of those. Okay, hold on, I'll be right back. We'll talk more about that. Back here, I had to find my cup of coffee. Got a little bit hoarse. I got it within reach now. Hey, I was talking about Shoblin lathes, and that was the first tool room grade lathe that I ever operated. And the reason I was able to operate that lathe, it was at a company that was doing work for the Whoops nuclear debacle back in the 1970s. And I was in the motorcycles of all kinds back then. And this is no kidding, I had an Atlas lathe with metric change gears so I could fix up foreign bikes. And someone told someone that, hey, that guy over there, my motorcycle mechanic, or a guy's kind of machinist, a motorcycle mechanic and all that, he can cut metric threads. So they asked me if I could cut some metric threads on the Shoblin lathe, and I go, sure. So anyway, it wasn't too bad. Now, an interesting thing about the Shoblin, and it's the same with rivet. It's sort of like Shoblin, I believe, had its roots in the watchmaking industry, and so did rivet. And so they come up with these lathes. The Rivet 608 is a really famous lathe, and I've always would like to have one. And they put a bunch of them on Navy ships in World War II, and there's quite a few of them around this area. I think they're still pulling them off ships and other machines too. Well, now that machine is more based on their watchmaking machines, the Rivet 608. So they come out with the 1020, 1030 series, I forget all the numbers of the 1020S, I believe. And no, that machine is a machine tool. It's like I think that's the only time they ventured into heavy conventional lathe. With the 608, it's more, the way it is, it's more like a watchmaker's lathe with plain spindle bearings, okay? And so was the Shoblin 102 VM that I used. It was really kind of a cool machine in a lot of ways, but it was metric only. I didn't cut that. We have ways to cut English threads here, so but they had some stuff and gave it the metric threads on it, and I was able to do it with that lathe, and it worked really good. And it was very simple lathe. I remember that it didn't have very many feeds on it. You changed belts on pulleys, but it had plain spindle bearings, okay? So Shoblin comes around I think in the 60s, 70s, to compete with all these other people that I haven't finished the list, who's all competing with Monarch for the big government money from these entities that are buying these extremely expensive lathes. So Schaublin, like rivet, and I know I'm going to irritate people saying this, but it's logical and the facts are the facts. Schaublin went bust on their larger lathes because they're unfriendly and hard to use, and they're metric only. This machine here is both English and metric. Beep, 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 no change gears, no nothing. Even the dials read both ways. Not so with others. So that's the problem with Schaublin. Their first machine, the 102, kind of a rounded old machine, which is fantastic. I'd like to have one, but they go for big prices. And so do the other ones. Now, the other ones, now see this 102 Schaublin, the early one, you change the belts, okay? You change the belts on pulleys to change the speed. Then the later ones, the square ones, they had a dreadful, horrible, and you can see it even on YouTube on older ones, variable speed pulleys. Now, the only lathe that really got away with that good is Hardinch. And I think because it's so simple, you ought to just see how simple a Hardinch variable speed drive is. It's incredibly simple. The rivet is a lot more complicated and quite a bit more prone to vibration. Hey, where's that coffee here? There, I clear my throat a little bit. Let's see here. So I was talking about that. So rivet had its roots in the watch trade, and so did Schaublin. And they both came up with machine tool style lathes like the Monarch 10EE, and they just didn't go over very good for a number of reasons, for a whole bunch of reasons. So those were big failures. And all of the other ones were too. The Hindi, because of the drive, the Lehman, because I don't know, it just, they only made just a few of them. It had an electric brake on it. And let's see. And some kind of it had a variable speed drive. And that Sydney, that was also branded South Bend with the weird tachometer on the very top. Kind of George Jetson-ish. But you can tell it's a Sydney by the build of the carriage and the levers on the carriage and stuff. And it was branded Sydney. It was also branded South Bend. And South Bend branded a couple of different variable speed lathes, and the Sydney one is the most rare. I've only seen 2 examples probably. Okay, so now we're down to Hardinch. Now Hardinch came from like the watch machines with their call-ups and all that, and it's successful. The Hardinch is absolutely a successful design, and there's limitations in it, and there's limitations in the Monarch 10EE too. But the Hardinch and the Monarch 10EE are the champion survivors, if you really think about it. Let's see what else I have on here. Oh, good old South Bend. Now, that's an interesting machine. South Bend has always held it home, but it, especially like the heavy 10s, until you get into the 13-inch and the 16-inch, they really struggle with like pre-hard It's really a monster on the heavy tin. I've had two of those in very good shape, and I like the Monarch heavy tin. Not the Monarch, the South Bend. But the best South Bend I had was a 13-inch. It was an earlier one with the single tumbler. I can't remember what year it was. It came out of an airplane repair place here. And it was just a fantastic machine. It had the collet rack and the hand wheel collets, and it was hand scraped, soft bed. It was in good shape and a nice machine. Okay, so that's the list. So hard inch no longer makes the machines anymore. So, but there's several clones, and they're quite good. One shop here had a feeler, and fellow seemed to like it quite a bit. So the difference I'll bring up about the hard inch and the Monarch here is power. Now, the hard inch only has 1 horsepower. It's the motor's a 2-speed, 1 horse, and then half horse. Now, this machine here has 5 horsepower. So you can do larger pieces that I found. Now, most of my experience is with the chucker, but I know a few people that have the HLBH, and one guy has that and one of these too. So what I found with the hard inch is it excels really well, keeps up with anything. It works a 5C collet better than anything because they invented it. But when I started getting over the size of capacity of a 5C collet, let's say 1 inch, and then using coolant, see, on the chucker, it's quite a bit heavy than the HLVH, and I could get away with using 221 negative brake inserts on that machine if I use coolant. And that was nice because they're real economical, and it was kind of some kind of tough stuff. I should get into that on a separate deal because I got another chucker here that I'm going to do stuff with. But now the Monarch 10EE, I'm going to point this out, that the factory steady rest, it only has a 3-inch capacity. And that's my experience with the machine. Once you get over 3 inches, it becomes more difficult to chase that plus or minus a tenth. So, okay. Now, I talked about that, and maybe I should make that a bit of a video, but we can have a quick look at the machine here, make it kind of more complete, and I will get more into the function of this great machine here. So here's the headstock end of the machine. We can look over the controls here. Here's your feed and thread selection right here, and it's in feed. And I'll show you how that feed works, and that's one of the nice features of this machine. It doesn't use the thread end train. Now here's your 2 speeds, A and B, for the quick change gearbox. Then it's got other levers here. The typical, this is your C, D, F for threads and feeds. When you're feeding, you can take the clutch off and switch this with the machine running. It won't hurt anything. The Axelson has a similar machine too. So if you want to change the gearbox selection, you drop this lever down here, and then this dial goes from 1 to 10. It sure moves easier than that, shifting that axle, man, I tell you what. But the gears will never give up. I don't think they'll ever give up. Here, so you select your threads. Here's your A, B. You see, then you get into the B range here. Then over here's your C, D, F, and here's your 1 through 10. This inch metric cuts a huge amount of threads here. So when you're switching over, all that you have to do is switch this here. This lever's feeds, and you can see there's inch, then all the way over is metric. So you have to shift this first, and then you shift this. And it's got an interlock. So you wiggle it, you wiggle the lead screw in. This will take it out of, it's in feed now. It'll put it into the lead screw. We'll go through that. And select what thread you want. Then you come over here, and right here is pitch in millimeters, threads, inch, and feeds. Yep. So when we're threading in millimeters, we'll flip this. You push these knobs in, and then the little ball comes out, and you can switch positions. That's how you shift these. Really classy, you know, the way this is. Then here's your feeds and threads. So if we're going to go metric, we go all the way over with this one, put this one up here in the direction of the thread we want to go, flip this over to millimeter, pull this up to threads. This here's your speed dial, and in and out for the back gear that is on the motor itself to isolate the machine from gears. What the axle sun is like full of gears. This machine eliminates that. Here's your instructions for shifting here. Okay, so you select your, you want to be in the feeds of the threads, and you just flip these levers. And when you want to go back to inch, all you have to do is push this one over 2 inch from here, and you leave that one alone, and then you come over here and slip that 1 notch. And when you go in the metric, the lead screw reverses because it engages a 127 tooth gear way back in the gearbox there. And so all of that reverses it, and so when you go up here, it'll show here pitch in millimeters left hand, but threads inch right hand. See, so it's opposite. If you want, you're going inch threads this way. If you want to go right hand threads, you have to flip it over here for metric, because all those gears reverse the lead screw. Once you got that selected, then you put the lever back up. You probably have to jiggle something. Yeah, that's pretty much how that is. Then you get over here to the carriage. Very, very simple. Now you don't want to move the carriage until you pump it up with oil. And you always want to store the carriage on one of these all the way to the right, just like it is here. And I'll show you the startup procedure. You don't want to move the carriage until you pump it up. It's actually stuck to the ways, and it's hard to move. You can move it with some force, but that's tearing metal up, you know. Okay, here's your longitudinal feed clutch here. Here's your cross feed clutch. Here's your, you flip that in, out, and in the center for threading. Okay, so that's your lockout feed, in and out, threading. This here is your lead screw reverse. Here's these forks here and these movable dogs. got a dog here. I think I locked it in. No, it'll come on over. Kind of hard to see under there. But you set this for threading, and you can thread at a few hundred RPMs right to the bottom of a blind hole. And it kicks off automatically. You either have to have a stop groove down there or pull the tool, watching a travel dial or your DRO. So you can do really high-speed threading right up the shoulders, and it's really, really a nice feature to have. But I'll tell you, after you get really experienced with the machine, you won't use it as much. But it is a really nice thing for the blind hole threading. And some tools like pullers and stuff, you want a threaded sleeve that's real thin. And you don't want a relief groove in the bottom because your puller tool or seal installer, bearing installer tool is probably more like what I'm thinking. That socket can break, so you want to pull the thread on stuff like that. So this is just a really outstanding tool maker's lathe. And I found the being able to switch back and forth so fast from English and metric brought me a bunch of work. And this was a machine that I really didn't put a lot of pan work out the door, but what it did was vastly improve the quality of the work I was doing in fixtures and things like that. I'll have to show you some of the funny fixtures that I might get a kick out of that. Well, this video is getting to be pretty long, and so I'll load this. And I pretty much ran over everything. Here's your control panel here. When you start the machine, we're going to do that. I still need to do that one setting, that speed compensation. I think you'll find that really interesting. So you flip this over, and the light comes on, and it starts warming the tubes up. Then this is your control panel. Here, your control on and off. And after the machine is on for 1 minute, then this lights up, and then you can push that. Then the machine's energized. Yeah, and I will get up. The last of it is right here. This is your electric lead screw reverse directional knob here. And if you put it in neutral, you lock everybody out of the machine, including yourself if you don't remember that. Okay, I'll be back. I think it's a good idea to move your tilt table every decade or so. This thing got pretty stiff. I'll rotate it for you. Now to get it started, yeah. You gotta do it like this. I got that vise on there. You get it to a point and you start cranking it. Let's see if I'm there. Lean into it. There we go. How about that? Yeah. That's some heavy stuff. I'm going to put it back because I'm flushing the oil out of it. Easier going that way. Okay, I'm going to go load this video. I hope you're all having a good day. I think we're going to have thunderstorms.